Here we're going to get started working with the normal distribution and using it to calculate probabilities for particular problems. We're going to start with a pretty straightforward and simple one so we can get familiar with working with the numbers, and then in some of the later videos you're going to see we're going to work with some more complex word problems. So we're going to be looking at exercise number 13, page 261 from your text. And we've got the problem here of being asked to find the probability of an IQ less than 85, given that we've got a mu of 100 and a standard deviation of 15. So this is our starting problem. Let's kind of walk through the steps we need to take to solve this problem. So what's the very first step we need to take in solving this problem? What do you think is going to be the first thing we need to do? Well, the first thing we need to do is we need to check our criteria for a continuous normal distribution. So Q is indeed a continuous random variable in the sense that we measure it, we don't count it. We're told to assume that the graph is symmetric and bell-shaped. So that's what we'd be having because our standard deviation would make the shape similar on both sides of the mu. So both of those are checked. So we've got that. So we know we have a continuous normal distribution. The next question is, does it meet the criteria for a standard normal distribution? Of course, we would prefer if it does. That makes it a lot easier to work with. So let's look at that, and it does not. So remember, our standard normal distribution has to have a mu of 0 and a standard deviation of 1, and that is not what we have here. This means we have to work with it as a normal distribution. So what we have to do here is convert our x to a z-score. All right, and for those of you that are feeling pretty familiar with what we worked on with the standard normal distribution, these problems are exactly the same in steps, with the exception that you must convert your x to a z. That's the only thing that's actually different. So we're going to go through the process, but notice that all you really do differently is convert your x to a z-score, and then you work from there. The rest of the steps are exactly the same. Okay? So we're going to go through and do this. We're going to use this particular formula we have here. And notice that whatever we're being asked to solve for is going to be our x. So here our x is 85. And here is our formula we use for calculating a z for a corresponding x. So pause the video here and take a moment and plug in your numbers and see what you get for your z value. And then once you've got that done, turn the video back on and we'll check our work together. Okay, so your formula should look like this. Your 85, that's your x value. You have your mu of 100, so that goes into the formula, and a standard deviation of 15. If you're finding yourself a little confused with numbers and feeling like you're getting a little overwhelmed with all these different values, I strongly suggest that you adopt what I've done here, which is start using a single color code for each of them. So make all of your means blue, make your standard deviations always green, and for example, your x value always red. And use your color combination, your color pencils, as you're building your notes and as you're solving the problems so you can keep this straight in your mind. This is a technique that I myself have used when I'm working with more complex problems. So if we take our calculations here and run them through, what do we get for our z-score? Take a moment and run those numbers and then turn the video back on to check that value. We're going to get a -1. So the corresponding z-score for an x of 85 is going to be -1. All right? So now we're going to go through the rest of the steps that we've already used before. And using the z distribution table, they're the exact same steps. And notice we're going to be solving, our probability notation is going to look like this. So we've got our probability of, and notice we're now giving our z because that's what we're actually looking for. We're not looking for our x, we're looking for our z. So we have z of less than -1, and what does that equal? All right, so let's go through the steps in solving this for our problem. So here's our quick graph that we're marking on what we know. We have a z of -1. Now notice our mu here is going to be 0 because we've converted it to the z distribution, to the z-score. So if we took 100 minus 100 and had 0 and divided it by 15, we would get 0. So the corresponding mu on the z-score table of 0 is for the mu of 100 on the normal distribution for the x. So now I've got my -1 and I've got my 0. So let's go look at our next step. Now here we know that it says it's less than 85. So that's telling us what direction we need to shade it. So take a moment, draw this little distribution into your notes, and then shade in the area that you think we're going to be solving for, and then move on to the next slide and we'll check our work. Okay, so you should have shaded the area to the left. That's what we're solving for. Okay? So we've got a z of -1, and we're solving for the area to the left of it. Now, keep in mind, our next step is solving it, keeping in mind that the probabilities in the z table always sum from the left. So let's take a moment to review over them, okay? Here we can see that we're solving for a less than, so the probability in the z distribution is exactly what we need. You can see the image up here, I've blown up for you and kind of labeled. Here going from the left, that is the less than component. So if you're being asked to solve for something less than, it's going to be all the information to the left of the z-score. If you're being asked to solve for something greater than, that is all the area to the right of that z-score. But remember, the z-table will not calculate that. So what you have to do is you have to take your area of 1, which is your full area, and you have to subtract out the area from the left, the area for your less than value, to get your greater than value, just as we did before. And lastly, keep in mind, if this was solving for a between problem, we would use our probability of z2 minus the probability of z1, just like we did before. So again, each of these steps is exactly the same as when we were working with the standard normal distribution. The only difference is we've got to take our x and convert it to a z-score first. That is the only real difference here. Okay, so we've got a -1 z-score on the outside of the table. Go through and look at, make sure you can find that corresponding probability. So pause the video here and go through and notice you're going to be looking and make sure you get the proper probability in the middle. Remember, you're going to be coming down your left-hand column for -1.0, and then you're going to come across the top for 0.00, and you come down that column and across the row for a -1.0, and the value where they intersect is going to be your probability. So pause the video and do that with your table, and then turn the video back on to check your work. All right, you should have gotten 0.1587, so that is our probability for this problem. So the solution for a problem like this is going to look exactly like we have here. So it's going to be probability of z. Make sure you're going to get your proper directional symbol in there, less than, greater than, right? -1, because -1 is the corresponding z value for the x of 85, and then the probability that you got from the z distribution table. Okay, now we're going to solve the same problem using the StatsCrunch software. A word of caution, on your homeworks and on your exam questions, I have done my best to identify and use problems that specify whether you should be doing the calculations by hand or by StatsCrunch. This is important because StatsCrunch will often give you a slightly different number. And if you're using the wrong version, you will get the problem wrong. If you find in your homeworks or the exam there is in fact a problem that does not specify you're supposed to be doing it by hand, or you're supposed to be using technology, then please email that problem to me going up to the top right-hand corner where you have the option to get help, and you can email the problem to your instructor so I can address that problem, okay? I've done my best to go through and check all of them, but every once in a while something slips through my radar and winds up in there. So please let me know if that occurs. All right, now we're going to be going into StatsCrunch, and if you need a referral, go back and look in the earlier slides where we talked at opening up StatsCrunch itself. So once you're in StatsCrunch, you're going to go through and open the option for stat, go down and select calculator, and then select the option normal. So pause the video here, open your StatsCrunch, and go through and take those steps. Once you've taken those steps and you've gotten your proper dialog box, then turn the video back on and let's look at the next steps you're going to take with that dialog box. Okay, you should have got something that looks a lot like this table over here on the right, this section of image over here on the right, but obviously without the values in it. So let's take a look at how you're going to plug these in. Some of them are pretty straightforward. Your mean, obviously, is your mu, right? Standard deviation, 15. Both of those plug in pretty straightforward. Remember that, notice this is solving for x, so it's kind of hard to see because of the purple arrow, but you should be able to see it on yours. It's solving for p of x, okay? Because that's what we're solving for now with StatsCrunch. Stats has to be very exact. Don't say you're solving for one thing when in fact you solve for something different, okay? So our x value is going to go in this middle box on the second row. So on that second row, we've got 3 different boxes. The middle box is where your value for x goes, and then you've got to make sure you're selecting the correct directional symbol here, all right, that you're coming into your problem. If you find that you're making errors at this level, then you need to go back and graph and shade the desired area first, and then begin the computations, okay? So once you've plugged these values in, you simply run your compute, and you're going to get your probability at the box on the far right side of the bottom row. Now, a word of caution with this is if you're looking at these problems and you're looking at using them to solve for between problems, notice they are not capable of doing that. So you're going to have to solve for the probability of getting your x2 and your x1 and then subtracting the x1 from the x2. Okay, so you're going to have to go through and do that calculation yourself. All right, so if you're solving for a between problem with a stats crunch, it will not solve for the between. You must select the solve for each of those values separately and then do the subtraction yourself. Okay, this concludes our practice problem going through and doing a basic problem solving a probability from a normal distribution. The next videos as we go on, we'll be looking at a central limit theorem and looking at some applets that go with that, and then solving for some more complex types of word problems.